Hello friends, welcome to the channel RS Tutor 11. So today's class is class 7 chapter 3 heat. Hot and cold. In our day-to-day life, we come across a number of objects. Some of them are hot and some of them are cold. Tea is a hot and ice is cold. Do not touch objects which are too hot. Yes, be careful while handling a candle flame or a stove. Why candle flame? Because of wax. Yes, basically candle is made up of wax. So when the wax is heated, it starts melting. Okay, and if the wax falls on your skin, then it just burns. Okay, it gives a burn marks. We see that some objects are cold while some are hot. You also know that some objects are hotter than others while some are colder than others. How do we decide which object is hotter than the other? We often do it by touching the objects, but is our sense of touch reliable? Yes. A reliable measure of the hotness of an object is its temperature. Temperature is measured by the device called thermometer. So basically to measure temperature we use the device thermometer. Okay. Next, measuring temperature. Thermometer that measures our body temperature is called clinical thermometer. Basically there are two types of thermometers. Okay, one is clinical and the other is laboratory. Okay, there are basically two types of thermometer, clinical and laboratory. See, clinical thermometer is used to measure the body temperature of a human body only, and laboratory thermometer is used to measure the temperature of objects. Okay, and therma means heat, meter means measuring. Okay, thermometer that measures our body temperature is called clinical thermometer. A clinical thermometer looks like this is your clinical thermometer. Okay, see how it is actually made. The clinical thermometer consists of a long narrow uniform glass tube. It has a bulb at the end. This is your bulb at the end. This bulb contains mercury. Outside the bulb a small shining thread of mercury can be seen. See this, here it is given clear. Okay, if you do not see the mercury thread, rotate the thermometer a bit till you see it. You will also find a scale on the thermometer. See, this is scale. The scale we use is the Celsius scale indicated by degree Celsius. Yes, its unit, see, unit of thermometer is, or thermometer is degrees Celsius. Okay, see here we'll see that how to read a thermometer. See, nowadays in each and every home, previously they only doctors used to carry it, but right now these days mostly 80 to 90% thermometer is present in each and every home. Okay, first note the temperature difference indicated by two bigger marks. Also note down the number of divisions shown by smaller marks. These are smaller marks. So this is division, small. Okay, scales between these marks. Suppose the bigger marks read 1 degree, there are 5 divisions between them, then one small division can read 1 by 5. So what is the answer of 1 by 2? Please, how many degrees Celsius? Do comment. Okay, in the comment box. So, wash a thermometer, preferably with an antiseptic solution. Hold it firmly and give it a few jerks. The jerks will bring the level of mercury down. Okay, ensure that it falls below 35 degrees Celsius. Next, now place the bulb of the thermometer. See, here it is, bulb is your side. Correct method of reading clinical thermometer under your tongue. After 1 minute, take the thermometer out and note the reading. This is your body temperature. So normal body temperature is 37 degree Celsius. Basically everyone don't have, this is a healthy body temperature, but some bodies have around 35 degrees Celsius to 42 degrees Celsius. Okay, so there ranges from this to this, a normal body temperature, but actually the most people body temperature, healthy body temperature is 37 degrees Celsius. What did you record as your body temperature? Okay, the normal temperature for human body is 37 degrees Celsius. Celsius is a unit of temperature. Note that the temperature is stated with its unit. Yes, the temperature of every person may not be 37. It could be slightly higher or slightly lower. Actually, what we call normal temperature is the average body temperature of a large number of healthy persons. The clinical thermometer is designed to measure the temperature of human body only. For measuring objects temperature, we use laboratory thermometer. The temperature of a human body normally does not go below 35 degrees Celsius or above 42 degrees Celsius. That is the reason that this thermometer has a range of 35 degrees Celsius to 42 degrees Celsius. Okay. Next comes the laboratory thermometer. As I said previously, there are two types of thermometer. One is clinical and other is the laboratory. Clinical is used to measure the human body temperature, whereas laboratory thermometer is used to measure the temperature of a object. Okay, so let us see here, how do we measure the temperature of other objects, that using the laboratory thermometer. For this purpose, there are other thermometers also. One such thermometer is known as laboratory thermometer. Okay, basically this is your what? Laboratory thermometer. See, the range of laboratory thermometer is generally from -10 to 110. Yes, and human body, I mean a clinical thermometer, clinical is 35 to 42. Yes, this is normal clinical thermometer, which is used to measure the human body, whereas laboratory thermometer, which is used to measure the object temperature. Also, as you did the case of the clinical thermometer, as we have taken, see, same way, a small division on this thermometer reads, you would need this information to read the thermometer correctly. So how to read a thermometer? Let's see. Okay, there is an activity. Take some hot water in a beaker or a mug. Dip the thermometer in water. Wait till the mercury thread becomes steady and note the temperature. Okay, steady means stable. Now take out the thermometer from water. Observe carefully what happens now. Do you notice that as soon as you take the thermometer out of the water, the level of mercury begins to fall? See, for laboratory thermometer, you need not to give any jerks. The mercury automatically falls down. But for clinical thermometer, you need to give jerks. Okay, you need to give some jerks to bring the mercury come down. Okay, so this is the difference. This means that the temperature must be read while the thermometer is in water. Okay, you may recall that while taking your own temperature, you have to take the thermometer out of your mouth to note the reading. Can you then use the laboratory thermometer to measure your body temperature? No. Why does the mercury not fall or raise in clinical thermometer? See, nor it is falling nor it is raising. You have to give some jerks, right? When you keep it in the mouth, what is the body temperature? The mercury goes up. While as if you want to bring the thermometer normal, okay, so you need to give some jerks. Do you see a kink near the bulb? Yes, we'll see it in next page. So basically this is your kink. Okay, so next comes the transfer of heat. You might have observed that a frying pan becomes hot when kept on a flame. It is because the heat passes from the flame to the utensil. Yes, when the pan is removed from the fire, it slowly cools down. Why does it cool down? The heat is transferred from the pan to the surrounding. See how heat is getting transferred? First, you kept a pan, excuse me, you kept a pan on the heat. Okay, then the heat is transferred to the pan. Yes, then if you remove the pan from the flame, what happens? The heat is transferred to the surrounding. Yes, so this is the transfer of heat. Next, so you can understand that in both cases the heat flows from the hotter object to the colder object. Yes, in fact, in all cases, heat flows from a hotter object to the colder object. So let us see, there is an activity. Take a rod or a flat strip of a metal, say of aluminium or iron. See, they are using a metal. Okay, fix a few small wax pieces on the rod. These pieces should be at nearly equal distance. Clamp the rod to a stand. Okay, this is your stand. This is your stand. This is a rod of metal or iron, and these are your wax. Okay, pieces of wax on the rod. So there's a candle. Okay, if you do not find a stand, you can put one end of the rod in between the bricks. They have used your bricks. Now heat the other end of the rod and observe what happens to the wax. See, you're heating this end, right? But it is affecting these ends. I mean, in between this rod. Are you understanding? So when you're heating this, there is a transfer of heat to the colder part of the rod. Yes. Transfer of heat. Here is a transfer of heat. You are heating one end which is hotter, and the heat is getting transferred to the other end of the rod, that is colder part of the end. Okay, which piece falls the first? Do you think that heat is transferred from the end nearest to the flame to the other end? Yes. See, first end will get heated, then the second, then the third, then at the end it will go. Okay. Next, the process by which heat is transferred from the hotter end to the colder end of an object is called conduction. Conduction. See, conduction, transfer of heat. See, these all are 1 mark questions. With example, they may ask you for 2 marks. So please revise this. Transfer of heat from hot object or end to colder end or colder object. Yes. Next, in solids, generally the heat is transferred by the process called conduction. It is for solids. Yes. The process by which heat is transferred from the hotter end to the colder end of an object is known as conduction. In solids, the heat is transferred by the process called conduction. Okay. The materials which allow the heat to pass through them easily are conductors. Yes. The metals, what are conductors? Which easily allows the heat to pass. The material, sorry, no, see, it should be, okay, we'll write a simple definition, need not to get so much of confusion. What are conductors? These are the materials through which heat can be easily passed. Through which heat can be easily passed is what? Is conductors. Of example, see, they have given all here metals itself, that is aluminium, iron, copper, as I said before, metal, but we shall use materials. Okay, we shall use materials here, the word. Why? Because it is in your textbook. So the materials which allow heat to pass through them easily are conductors. What is conduction? The heat is transferred by the process called conduction in solids. And what is actually the conduction? The process by which heat is transferred from the hotter end to the colder end of an object is known as conduction. Okay. Next, the materials which do not allow the heat to pass, which are bad conductors, are or slow poor conductors of heat, such as plastic and wood. See, if you pass the heat through them, they don't pass, right? Plastic will get burnt off and wood will also get burnt off. Yes, poor conductors are known as insulators. The heat which does not allow heat to pass through them. What are insulators? Does not allow or doesn't allow heat to pass through them are insulators. Yes, the water and air are poor conductors of heat. See, you cannot pass heat from water and air. Okay. Next, then how does the heat transfer to take how does the heat transfer take place in these substances? Okay, next there is activity 3.8. Take a round bottom flask. See, this one it is. So this is beaker basically. If the flask is not available, beaker can be used. Yes. Fill it 2/3 with water. Place it on a tripod or make some arrangement to place the flask in such a way that you can heat it by placing a candle below it. Wait till the water in the flask is still. Place a crystal of potassium permanganate, yes, at the bottom of the flask gently using a straw. Heat the water by placing the candle just below the crystal. Okay. Next, what you observe, that is this part. Okay. That is convection of heat in water. Okay. When water is heated, the water near the flame gets hot. This part. Yes. Okay, the cold water from the sides moves downwards down towards the source of heat. This water also gets hot and rises, and water from the sides moves down. This process continues till the whole water gets heated. This mode of transfer of heat is known as convection. Best example, you're preparing a tea. Yes, you're preparing it on a stove. Okay, just imagine this is your flame or gas. Yes, this is your water. Okay, so what happens here is the first part is this part of the water will get hot. This part of the water will get hot. Yes, slowly this will start forming vapors. Yes, this thing, then the side water will get downwards, the cold water will come downwards. Yes, and this, then the complete process, okay, the whole water gets heated. That is mode of transfer of heat is called convection. Okay, this is the convection, that is the process till the water gets the mode of heat transfer known as convection. Yes, yes. See, conduction is different and convection is different. Okay, conduction is movement of water, uh, transfer of heat from hotter object to colder object. Convection is the mode of heat transfer. Okay, that is the water, this complete becoming hot is convection. Okay, next, light a candle, keep, see one more they have given activity. Light a candle, keep one hand above the flame and one hand on the side of the flame. Do your hands feel equally hot? No. See, this part of your hand, this upper part may feel, see if you are holding it closer, this may feel hot, but not this one. Yes, notice that towards the top, the air gets heated by convection. Yes, convection, transfer of heat. Therefore, the hand above the flame feels hot. On the sides, however, there is no convection and air does not feel as hot as the top. See, sometimes we get burnt here, but not here. Okay. The people living in the coastal areas experience an interesting phenomena. Coastal areas are nothing but as a boundary area. Okay, nearer to the seas or oceans, gets heated faster than the water. The air over the land becomes hotter and rises up. The cooler air from the sea rushes in towards the land or take its place. The warm air from the land moves towards the sea to complete the cycle. Excuse me. As you can see in this figure 3.11. Okay, see, during the daytime, this is daytime, this is nighttime. During the daytime, the land gets heated. Yes, this gets heated. Okay, then the water, faster than the water. The air over the land becomes hotter and rises up. Yes, the air over the land, this air becomes hot. Okay, and rises up. The cooler air from the sea rushes in towards this, rushes towards the land to take its place. The warm air from the land moves towards the sea to complete the cycle. Okay. Next, the air from the sea is called sea breeze. The air which is coming from the sea. Yes, the air which is coming from the sea is sea breeze. To receive the cooler sea breeze, the windows of the houses in coastal areas are made to face the sea. At night, it is exactly the reverse. Okay. The water cools down more slowly than the land, so the cool air from the land moves towards the sea. This is called land breeze. See, this phenomenon is becoming, say, during the daytime, the land is hot, and during the night time, the land is cold. Yes, the water cools down more slowly than the land, so the cool air from the land moves towards the sea. This is called the land breeze. Sea breeze is air coming from the sea, and land breeze is air coming from the land. When we come out in the sun, we feel warm. Yes, we feel warm. How does the heat from the sun reach us? See, it does not any transfer any heat. It is through radiation, UV radiations. Basically, females or some other males also use sunscreen. Yes, SPF. Okay, it cannot reach us by the conduction or convection, as there is no medium such as air in most part of the space between the earth and the sun. From the sun, the heat comes to us by another process known as radiation. Yes, UV radiation. The transfer of heat by radiation does not require any medium. It can take place whether a medium is present or not. When we sit in front of a room heater, we get heat by this process. A hot utensil kept away from the flame cools down as it transfers heat to the surrounding by radiation. Okay, our body too gives heat to the surroundings and receives heat from it by radiation. Okay, see, we people are not anything, so that we and sun is also not, see, it is just giving radiations, right? It is not giving any flames and all so we people can get hot and it's not like that. So basically the sun is radiating its rays, okay, that is radiation. So all hot bodies radiate heat. When this heat falls on some object, a part of it is reflected, a part is observed, and a part may be transmitted. The temperature of the object increases due to the observed part of heat. Okay, the temperature of the object increases due to the observed part of the heat. Next, so I'll give an example. You people will be sitting in the class, right, on the bench. When you sit, that place will be cold. Okay, when you get up, just check that place temperature. Yes, because it has observed the heat. Okay, so the temperature of the object increases due to the observed part of the heat. We often use electricity and fuels like coal and wood to keep our houses cool or warm. Yes, electricity, AC, VC and all. Is it possible to construct buildings that are not affected much by heat and cold outside? This can be done by constructing outer walls of buildings so that they have trapped layers of the air. One way of doing this is to use hollow bricks, which are available these days. Next, still there is an activity again. Take two identical tin cans, paint the outer surface of one black and the other white. See here, the darker the objects, the here it is, the heat observed is more. Yes, the darker the shade. Here we'll see that only. Pour equal amount of water in each and leave them in the midday sun for about an hour. Measure the temperature of the water in both the cans. Do you find any difference? Yes, this will be hot. This will be not that much. Okay. You can feel the difference even by touching water in two cans. Next, fill the two cans used in activity 3.10 with the same amount of hot water at the same temperature, that is 60 degree. Leave the cans in a room or in a shade that the temperature of water after 10 to 15 minutes. Does the temperature of water in both the cans fall by the same amount? Do these activities suggest to you the reason why it is more comfortable to wear white or light colored clothes in the summer and dark colored clothes in the winter? Yes, see, during summer, most of our ancestors also used to say, now our parents say us that during summer wear cotton clothes, prefer to wear cotton clothes for the easy transfer of heat or air through the body. Yes, and don't wear black or see black or any dark color, dark in the sense, why? Because it is easily, heat is easily observed. Yes, heat is easily observed in the summer, so they try to avoid to wear dark color clothes as well as heavy clothes in which heat is not easily transferred. They avoid this, so they wear cotton. Most probably fiber fabric they use is cotton fabric. But in winter it is opposite. We use the woolen clothes made up of animal wool. Yes, dark surface absorb more heat, therefore we feel comfortable with the dark colored clothes in winter. Light colored clothes reflect most of the heat that falls on them, and therefore we feel more comfortable wearing them in the summer. Okay, as I said you. Next, woolen clothes keep us warm in winter. In the winter we use woolen clothes. Wool is a poor conductor of heat. Yes, moreover, there is a air trapped in between the wool fibers. See, you cannot wear winter clothes in summer, right? Because there is no transfer of air properly. Yes, this air prevents the flow of heat from our body to the cold surrounding, so we feel warm. Okay, what was in this chapter? Let's go through that. Our sense of touch is not always a reliable guide the degree of hotness of an object. Temperature is a measure of the degree of hotness of an object. There are two types of temperature, which are they? Clinical and laboratory. Thermometer is a device used for measuring temperature. Clinical temperature thermometer is used to measure our body temperature, that is human temperature. The range of this thermometer is from 35 to 42 degrees Celsius, whereas laboratory thermometer ranges from -10 to 110. Yes, the normal temperature of a human body is 37 degrees Celsius. The heat flows from a body at a higher temperature to a body at a lower temperature. There are three ways in which heat can flow from one object to another. These are conduction, see here it is conduction, convection and radiation. Okay, next, in solids generally the heat is transferred by conduction. In liquids and gases the heat is transferred by convection. Okay. No medium is required to transfer heat by radiation. The materials which allow the heat to pass through them easily are conductors, and which does not allow through them to pass easily are insulators. Dark colored objects absorb more heat compared to the light colored objects. That is the reason we feel more comfortable in light colored clothes in summer. Woolen clothes keep us warm during winter. It is so because wool is poor conductor of heat and it has a air trapped in between the fibers. Yes, so any doubt? Go through the topic once again. Okay, go through the video once again. So thank you for watching the video. Here completes the chapter heat, class 7th. Okay, so any doubt, go through the video once again. Thanks for watching. Don't forget to like, share, subscribe the channel. Thank you.